Good morning, Namaskar. Am I audible? Please check audio and video. Uh, Welcome back after a long break. But I have forgotten what was the last topic. So I request to anyone, please put the last topic in the comment box so that I can start. Either in the comment box or you can take photo and photo of the last topic and send it into the group Anunad so that I can see ki where I have to start. एकदम पूरी तरह से भूल चुका हूं मैं कि लास्ट टॉपिक मैंने कौन सा आपको पढ़ाया था। तो आप प्लीज़ कमेंट बॉक्स में लिखें कि व्हाट वाज द लास्ट टॉपिक ताकि शुरू किया जा सके। सो आई एम वेटिंग फॉर योर रिस्पॉन्स। Waiting for your response. So thermal properties of ceramics. This was the last topic. Good. So let's begin with this. Thermal properties did I covered or I have to cover? Thermal properties पढ़ाना है या पढ़ा चुका हूं? Good. Thank you. Thank you for your response. Thermal properties. Shall I have to start or I have completed it? Sunanda is saying it is first live class. Sunanda, have you covered the earlier lectures or not? If it is the first lecture, it would be very difficult for you to absorb. Okay, mechanical properties of ceramics has been covered and we have to start with the thermal properties. So let us begin with the next heading, that is thermal properties of ceramics. Thermal properties of ceramics. It is very cold today in Delhi, so writing is becoming very difficult. I am a bit shivering, so it's becoming difficult to write. Right. Okay, sir, covered 4 points and the so there were the 4 points only. Let me reiterate those 4 points again. 5 points were given, right? 5 points were given, right? So I may have given these points. Ki ceramics have high melting point. Ceramics have high melting point. This we may have discussed. This in fact I discussed in the ionic bond topic itself. I told you there ionic bonded materials are strongly bonded and their bonding energies are very high in the range of 1500 kilojoule per mole, like that. So we have to move here onwards. Second property I have told you कि ceramics are thermal insulators, yeah, are excellent thermal insulators, excellent thermal insulators. And third, I may have told you कि ceramics have poor thermal conductivity and coefficient of thermal expansion. Ceramics have poor thermal conductivity and coefficient of thermal expansion and coefficient of thermal expansion. Poor thermal conductivity and coefficient of thermal expansion. Fourth, I may have told you कि ceramics can withstand thermal shock, can withstand thermal shock. So they do not normally creep, say, so they do not normally creep up to workable high temperatures, to workable high temperatures. They do not normally creep up to workable high temperatures. This we have discussed, all these 4 points we have discussed. Sir, roughly how much time it will take to complete ceramic chapter? Didn't attend last class of ceramics. Thermal properties of ceramics are written till date only. Okay. Sir, I have covered 2 units of what you have taught till now. I will cover the rest too in meantime. Good, good. Keep on studying. So, this we have already covered. Here onwards we have to start. One moment please. सुनो, कोई दूसरी पेन नहीं है, बड़ी मोटी है यार. यही पेन है सारी, यहाँ पेंसिल वाली नहीं है. देखो अगर हो तो. इसकी आदत नहीं है, बड़ा हेवी लग रही है. ठीक है, थैंक यू. दोनों रहने दो. तुषार अग्रवाल कह रहे हैं एक मसाला चाय ले लीजिए, वर्केबिलिटी थोड़ा बेहतर है. अभी एक्चुअली जो सपोर्टिंग स्टाफ है वो बहुत कम आया हुआ है और रेगुलरली ये जो क्लास आपकी लगती है, दिस इज़ फ्रॉम द स्टूडियो जहाँ से क्लासेस होती हैं, बट आज हेड ऑफिस से क्लास हो रही है और हेड ऑफिस जनरली 9 बजे के बाद खुलता है क्योंकि यहाँ क्लासेस नहीं होती हैं. सो अभी स्टाफ बहुत कम है. हेड ऑफिस इसलिए आज आना पड़ा है कि आपको पता होगा रिसेंटली यूपीएससी हैज़ अनाउंस्ड इंजीनियरिंग सर्विसेज 22 का रिज़ल्ट आया हुआ है. तो उस रिज़ल्ट में बहुत सारे बच्चों ने बहुत अच्छा प्रदर्शन किया है. दे हैव क्रैक्ड दैट एग्जामिनेशन और उन्होंने टॉप किया है. इस साल मेडी जी का रिज़ल्ट मेडी जी के इतिहास में सबसे बेहतर है. पर्टिकुलरली मेरे लिए तो बड़ी खुशी की बात है कि ईसी में मेरी ब्रांच में 3-4 स्टूडेंट शायद मेडी जी के नहीं हैं, बाकी सारे के सारे मेडी जी के स्टूडेंट हैं और मैक्सिमम क्लासरूम के स्टूडेंट हैं. जो आप लोग पढ़ रहे हो जिस तरह से कंप्लीट जो कोर्स है उसके स्टूडेंट हैं, तो उनके साथ एक टॉपर स्टॉक सीरीज चलती है, तो उसकी रिकॉर्डिंग के लिए न्यूज़ रूम में बुलाया गया है. तो मैंने सोचा सुबह आपकी क्लास ले लेते हैं और उसके बाद रिकॉर्डिंग कर लेते हैं. सो यहाँ अभी थोड़ा सा लोग कम है, स्टाफ कम है, इसलिए चाय की सुविधा थोड़ी देर बाद होगी, तब तक थोड़ा मैनेज करना पड़ेगा. चलिए शुरू करते हैं. Up till now we have covered the properties of ceramics. On the basis of these properties, there are few fundamental applications of ceramics, and sometimes UPSC asks questions from these applications. So, first application is refractories. Refractories या refractory material. Refractories या refractory material. Refractory material, these are the materials used to make फर्नेसेस. ये मटेरियल्स हैं जो फर्नेस बनाने के लिए काम आते हैं. मैंने टॉपर स्टॉक में बहुत सारे स्टूडेंट से इन डेप्थ डिस्कस किया है कि कैसे जीएस की स्ट्रेटजी रखी जाए. आप उन्हें सुनिएगा जो अभी टॉप किए हैं, रैंक 3, रैंक 4, रैंक 5, ऑल दिस. सो यूट्यूब पर आ भी गया है कई सारे वीडियोस, तो उन्हें सुनिएगा, आपको एक आइडिया मिलेगा कि हाउ यू शुड प्रोसीड फॉर द प्रिपरेशन ऑफ जनरल स्टडीज. सो दीज आर द मटीरियल्स यूज्ड टू मेक फर्नेसेस या क्रूसिबल. Actually, crucible is that pot in which molten metal is kept, and furnace की जरूरत ये पड़ती है कि when we do metallurgy, so we need a furnace, and in this furnace we need to increase very high temperature so that we can do metallurgy. So basically metals are available in their molten state in this furnace. So first requirement of furnace material, this wall is made of the refractory material. So the first requirement of these furnace materials या refractory materials is कि they should have capability to withstand very high temperature. ये ऐसे मटेरियल होने चाहिए जो बहुत ज़्यादा टेम्परेचर को बर्दाश्त कर सकें, यानी इनका मेल्टिंग पॉइंट हाई होना चाहिए, पहली रिक्वायरमेंट. सेकेंड रिक्वायरमेंट, दे शुड बी थर्मल इंसुलेटर्स, सो दैट अंदर जो आपने टेम्परेचर डेवलप किया है, दिस शुड रिमेन इनसाइड द फर्नेस, इट शुड नॉट गो टू द आउटसाइड, इट शुड नॉट गो बेसिकली टू द environment. So if the material is conductor, then the temperature will go to the environment, but if the material is insulator, this temperature will retained in the furnace. So it should be thermally insulator. In fact, heat reflection की property होनी चाहिए. Whatever heat is coming to the wall, this should be reflected back so that it could not transmit through the wall. So this material should be reflective in nature for the heat. नेक्स्ट प्रॉपर्टी ये होनी चाहिए, क्योंकि इसमें आप मेटल रखेंगे मॉल्टन स्टेट में, सो एट हाई टेम्परेचर दैट मेटल विल बी इन मॉल्टन स्टेट एंड दैट विल पुट प्रेशर ऑन द वॉल. So this material should have capability to withstand load, to withstand pressure at high temperature. So it should have capability to withstand a load at very elevated temperature. ये इसकी अगली प्रॉपर्टी होनी चाहिए. नेक्स्ट इसमें यह होना चाहिए कि इट शुड नॉट रिएक्ट विद द मेटल, या जो इम्प्योरिटीज हैं ड्यूरिंग मेटलर्जी, जो इम्प्योरिटीज बनती हैं ड्यूरिंग मेटलर्जी उन्हें स्लैग कहते हैं. सो दिस शुड नॉट रिएक्ट विद द मेटल या स्लैग, यानी इम्प्योरिटीज ड्यूरिंग द मेटलर्जी जो होती हैं उन्हें स्लैग कहते हैं. क्यों? अगर इसने इम्प्योरिटीज या स्लैग के साथ रिएक्ट किया तो क्या होगा कि ये मटेरियल रिएक्ट करके कुछ नया बनाएगा और वॉल आपकी खत्म होती चली जाएगी. सो ओवर द पीरियड ऑफ टाइम योर वॉल विल गेट कोरोडेड एंड योर फर्नेस विल गेट डिस्ट्रॉयड. सो इन ऑर्डर टू अवॉइड दिस थिंग, इट शुड बी हाईली नॉन रिएक्टिव, इट शुड नॉट रिएक्ट विद द मेटल या impurities formed during the metallurgy. Next important properties, it should be highly non-porous. There should not be micropores, yeah, there should be negligible micropores, because if the material is porous, then those pores will help to transfer the heat. So in order to avoid that heat transfer through the pores, it should have high degree of non-porosity, as well as one very important property, that is strength, that is also being affected by the porosity. If material is very porous, then its strength would be down, but if it is highly non-porous, its strength would be high. हालांकि completely non-porous पाना difficult है, because most of the furnaces are made of a mixture of materials. So when we took a mixture of materials, then every material has different molecular size, atomic size, and because of differing molecular or atomic size, there will be micropores in the structure of the material. So if you want to avoid the micropores, then you should use pure material, but pure materials are costly affair, so that will enhance the cost of the structure. So in order to reduce the cost of the structure, we generally avoid using pure materials, and hence there would be certain degree of non-porosity. But while fabrication, we should keep in mind that this porosity should be minimum and structure should be highly non-porous. So these are the certain properties which must be available in the refractory materials. So let us summarize these properties. So keep on writing with me all these properties. Refractory materials, refractory materials should have high melting point, should have high melting point. Second, should have high thermal insulation or heat reflection property, or heat reflection property. Should have capability to withstand load at should have capability to withstand load at elevated temperatures. At elevated temperatures. Should not crumble or crack easily. Should not react. Should not react with molten metal or slag. Should have high degree of non-porosity. Should have high degree of non-porosity. These are the few fundamental properties which should be available with the refractory material. ऑनलाइन कोर्स से भी रुचि काफ़ी लोगों का सिलेक्शन हुआ है। आज जो ऐड आया है उसमें किस कोर्स में स्टूडेंट ने एडमिशन लिया था, कोर्स वाइज पूरी डिटेल उसकी रैंक और फोटो के साथ, और उसने मेडी जी के किस कोर्स में एडमिशन लिया है सारा शेयर किया गया है। मैं अनुनाद पर शेयर कर दूंगा। So that complete detail has been given over there कि in which course he has taken admission, he or she has taken admission. Girls का काफ़ी अच्छा रिजल्ट आया है, so मतलब the ratio of girl and boys candidate is better, so the result is very impressive. सर हर फैकल्टी को पेंसिल वाली पेन ही क्यों अच्छी लगती है, अभिषेक सिंह नेगी पूछ रहे। बेटा लाइट इन वेट है एक्चुअली, जो दूसरी पेंसिल है, जो दूसरी पेन है ब्लैक वाली, ये बहुत हैवी है। ये दिखने में तो हल्की है बट इसके अंदर पता नहीं रबर वगैरह भर रखा है, सो वेरी हैवी है। और जो पेंसिल वाली है वो लाइट इन वेट है। Ritvik Narayan ji, this is the first topic, first slide. Written? Now let us quickly see what are various types of furnaces या refractories. So the first one is fire clay refractory. You can write types of refractories. Types of refractories. First one is fire clay refractory. Fire clay refractory. This is made of the mixture of clay, basically fire clay. Fire clay is that clay in which the oxide component is very high. This is the clay in which calcium oxide, magnesium oxide, all these are very high. That clay is known as fire clay. Actually, this is the clay which is found in near about the water bodies like pond या river के किनारे की जो मिट्टी है, that is having the property of fire clay. So fire clay and along with the fire clay it contains alumina and silica. So it is made of fire clay. It is made of fire clay plus alumina plus silica. So it is mixture of so many compounds, etc. Being mixture of so many compounds, it is highly porous. So its load bearing capacity is very less and it needs some external support. इसका एक बेस्ट एग्जांपल दूं, आपने कभी तंदूर देखा होगा जिसमें तंदूरी रोटी बनती है, या अर्दन ओवन जो होते हैं ग्रामीण इलाकों में, चूल्हे जो यूज होते हैं मिट्टी के बने हुए अर्दन ओवन, तो उनको अगर आप देखिए, सो दे आर नथिंग बट द फायर क्ले structures या fire clay refractories. So they are generally provided some external support. Like if you have seen the tandoor is made in the steel structure. It is supported by the steel structure. So these kind of structures, because of being highly porous, has very less load bearing capacity, and also they can withstand very less temperature. So generally they need certain external support. The beauty of this structure is it is relatively inexpensive. So the best thing about it is relatively inexpensive, बहुत ही सस्ते होंगे as comparison to the other refractory materials. The second one is silica refractories. Silica refractory. Here the major constituent is silica, but along with the silica other components are also used. So major constituent is silica. Major constituent is silica. Silica is SiO2. Silica is acidic in nature. So this refractory is also known as acid refractory. So these silica refractories are also known as acid refractories. These are good for the materials which are acidic in nature, because acid और acid तो react नहीं करेंगे. So उन materials की metallurgy करने के लिए you can use acid refractories. But if you have impurity or the material of basic nature, then you cannot use this, because acid और base एक दूसरे से react कर लेंगे and then you will not be getting the good result. वो salt बना करके आपकी furnace ही गायब हो जाएगी. So in order to avoid this, for the basic materials या the materials which have basic nature, for them you need certain different kind of refractory, and that refractory is made of the magnesia. So third one is basic refractories. Basic refractories, and these basic refractories are made of magnesia. The major constituent is magnesia. The major constituent is MgO. MgO is magnesia. So these are magnesia based refractories. Suppose in any application you have acid and base impurities both, and you want to process them. So you need both refractories, so that acid material can be processed in acid refractory and basic material can be processed in basic refractory. But there is a problem, both of these refractories can react with each other. So in order to isolate them, we use a neutral refractory so that they cannot react with each other. किसी के दिमाग में ये भी आएगा कि क्यों ना ऐसे एप्लीकेशन के लिए हम न्यूट्रल रिफ्रैक्टरी ही बना दें, पूरी की पूरी फर्नेस ही न्यूट्रल कर दें, बट दैट बिकम्स वेरी कॉस्टली प्रोसीजर. सो वी यूज न्यूट्रल रिफ्रैक्टरी जस्ट टू अवॉइड जस्ट टू प्रोवाइड द आइसोलेशन बिटवीन एसिड एंड बेस रिफ्रैक्टरीज. इसके अलावा हम पूरी की पूरी फर्नेस नहीं बना पाते क्योंकि वो बहुत ही ज़्यादा कॉस्टली हो जाता है. सो नेक्स्ट वन इज न्यूट्रल रिफ्रैक्टरीज. Neutral refractories. Neutral refractories. न्यूट्रल रिफ्रैक्टरीज में हमारे पास ये क्रोमाइट बेस्ड रिफ्रैक्टरीज होती हैं. सो दीज रिफ्रैक्टरीज इंक्लूड क्रोमाइट. दीज आर क्रोमाइट बेस्ड. Chromite is basically FeCr2O4 based, and these are used to isolate acid and base refractories. These are used to isolate acid and base refractories. गुड सुनंदा, आपकी नानी जी साइंटिस्ट थी, देखो उन्हें पता था कि नदी के किनारे की मिट्टी की रिफ्रैक्टरी कैपेबिलिटी ज़्यादा होगी, इसीलिए वो चूल्हा बनवाने के लिए नदी के किनारे से मिट्टी मंगवाती थी। किसी ने ये डिफिनीशन दिखाने के लिए कहा था, प्लीज क्विकली डू इट। Actually, science is all about experiments. So, over the period of time, people have done experiments, and on the basis of those experiments, we got to know which one is good for us and which material is not good for us. So, earlier people were knowing, but they were not knowing the reason, they were using it. And now, when we are studying, so we know the reason, but we are not doing the experiments. So now it's our responsibility when we come to know about the reason of any particular material or anything, we should explain it to the people, those who are using it without knowing the reason, so that better understanding and awareness society में develop की जा सके. Shall we go ahead? Done? Shall we go ahead? Okay. Next one is special refractories. As the name is indicating, they would be used for the special purposes. So, special refractories. These are made of relatively pure materials, so they are highly non-porous. Pure oxide, pure carbides, pure nitrides, pure silicon oxide, like that. So they are used to make these furnaces. Because of high purity, these furnaces are non-porous and they have high load bearing capacity, as well as they can withstand very high temperature. So they can be used for those applications where we need very high temperature need to be produced in the furnace. But since they are made up of the pure materials, so they are very costly. So cost become one big restriction behind the uses of these furnaces. But those applications where cost is not a limiting factor, then you can use these furnaces to get the best performance of refractory materials. So first write this. These are made of relatively pure oxides Al2O3, SiO2, B2O3, etc. Carbides TiC, WC, SiC, etc. Carbides. and nitrides Si3 and 4 etc. with a very high degree of non-porosity, with a high degree of non-porosity. Being highly non-porous, they have high load bearing capacity, load bearing capacity and high temperature withstanding capability, temperature withstanding capability. But these are extremely expensive, but these are expensive. जो कार्बाइड्स हैं, metal carbides, they are very good refractory materials, but they have one big problem. They start getting oxidized. Oxidation का मतलब corrosion समझिए आप. So furnace का corrosion होने लगेगा. They get oxidized at temperatures greater than 1000 degrees centigrade. So their use is limited up to that temperature. If you are wanting to go beyond 1000 degrees centigrade, then metal carbides are not good. But among the carbides, silicon carbide is very exceptional. Actually, what happens, let us suppose this furnace is of SiC. So यदि अंदर आप टेम्परेचर हाई करेंगे तो SiC के सरफेस पर टेम्परेचर बढ़ेगा एंड इनर सरफेस में अप टू फ्यू नैनोमीटर इसका ऑक्सीडेशन होगा. So carbon will make carbon dioxide and it will go into environment, but silicon will make silicon dioxide. This silicon dioxide is very good insulator. So a protective layer of SiO2 will be formed at the surface of this material, which protects the main body of the material, because SiO2 is insulator, so it will not allow heat to enter inside the refractory material, and hence the main body of material will remain protected. So SiC can be used for very high temperature applications. ये 1500 डिग्री सेंटीग्रेड या उससे ज़्यादा टेम्परेचर तक के लिए भी यूज किया जा सकता है. So among the carbides, SiC is exceptional and it can be withstand high temperature, whereas other carbides may start getting oxide roughly around at 1000 degree centigrade. So next point यही लिखेंगे, metal carbides get oxidized at high temperatures. However, SiC is exceptional among the carbides and can withstand या can be used for very high temperature applications, can be used for very high temperature applications. At high temperatures, SiC forms a layer of SiO2 which protects the main body of material, which protects the main body of material, which protects the main body of material, and hence it can withstand very high temperature, and hence it does not oxidized at elevated temperatures. Please note it down. यार ये कुछ लैग कर रहा है बोर्ड, पेंसिल की वजह से या बोर्ड की वजह से। हाँ मतलब लिखते हैं छूट जाता है कुछ वर्ड्स उसका। हाँ हाँ करवाइए, क्योंकि इसमें भी ये बहुत सर्कुलर हो गया है, उसकी वजह से भी हो सकता है, इसकी वजह से भी हो सकता है। चलो देखते हैं। थैंक यू। कितने बजे आता है निरंजन? अच्छा ठीक। डन, गुड। कार्बन एंड ग्रेफाइट, बेसिकली ग्रेफाइट ही कार्बन है, कार्बन तो एलिमेंट है, रूम टेम्परेचर प्रेशर पर जो कार्बन का फॉर्म है वो ग्रेफाइट है। दैट इज आल्सो अ वेरी गुड रिफ्रैक्टरी मटेरियल, बट उसकी एक ड्रॉबैक है कि वो 700 डिग्री सेंटीग्रेड से एबव टेम्परेचर, सॉरी 800 डिग्री सेंटीग्रेड से एबव टेम्परेचर पर ऑक्सीडाइज होने लगता, और कार्बन अगर ऑक्सीडाइज्ड होगा तो वो कार्बन डाइऑक्साइड बना करके इन्वायरमेंट में उड़ जाएगा। So, carbon या graphite based furnaces can be used for high temperature application, but always below 800 degree centigrade. Above 800 degree centigrade they are not suitable. So, you can write this point also. Note: carbon and graphite are also very good refractory material, are also very good refractory material. Carbon and graphite are also very good refractory material, but they get oxidized at temperatures excess of 800 degree centigrade, but they get oxidized at temperatures excess of 800 degree centigrade. लिख लीजिए। फर्स्ट पैराग्राफ ऑफ स्पेशल रिफ्रैक्टरीज किसी ने कहा था, प्लीज सी इट। चलिए एक और application. There is one more application, that is abrasives. Abrasives are materials which are used to cut, grind or wear out any other material. किसी मटेरियल को कट करने के लिए, ग्राइंड करने के लिए या वेयर आउट करने के लिए जिस मटेरियल की जरूरत होती है उसे एब्रेसिव कहते हैं. बेसिकली दीज आर कटिंग टूल्स. Now suppose I want to cut this material with the help of this tool. So obviously the tool material should be harder than this one, then only ये cut कर पाएगा. So any hard material can cut the softer materials. This is the basic thing which we require. So first property for the abrasive is कि they must have high degree of hardness. They should be very hard material. But when you start cutting, my dear friend, at that moment some frictional forces will also come into the picture. So due to these frictional forces, some heat would be produced. If the tool will absorb heat, its bonds will become weaker and it may break down. So this tool material must be refractory in nature also, so that whatever heat is being developed, it is being reflected to the environment और ये खुद में absorb ना करे. Both of these properties are available with ceramics. Ceramics are very good refractory material and ceramics have very high hardness. But there is one problem. When you cut it, shocks will come. And ceramics are brittle material. They cannot withstand shock. They cannot withstand sudden load. The shock absorbing property is toughness, and brittle materials have very low toughness. So this problem is available there, and we need some degree of toughness also in order to absorb the shock which will be coming during the cutting action. So what we do, we take two materials. Let us suppose we take one metal and at the cutting surface we reinforce ceramics. So hardness and refractoriness will be provided by the ceramics, and whatever shocks will come, that will be absorbed by the metal. So this way metal and ceramic tool का mixture जब हम बनाएंगे, so that will be used as an abrasive. Since the cutting action is being performed by the ceramics and metal is only providing the support to absorb the shock, that's why I am discussing this topic here in the ceramics, although it is a composite material. So let me write it. सुनंदा अप टू 1500 डिग्री सेंटीग्रेड इट कैन विदस्टैंड. हालांकि बहुत अच्छे से बनाया जाए तो 2200 डिग्री सेंटीग्रेड तक भी विदस्टैंड कर सकती, बट इन नॉर्मल एप्लीकेशन SiC कैन विदस्टैंड रफली अराउंड 1500 डिग्री सेंटीग्रेड. एब्रेसिव मैं बोल रहा हूं, आप लिखिए. अच्छा, डायमंड इज द हार्डेस्ट नोन मटेरियल. सो इफ यू मेक एब्रेसिव या कटिंग टूल विद द हेल्प ऑफ डायमंड, यू कैन कट एवरीथिंग. बट डायमंड इज expensive, costly affair. So diamond has its limited application, and that is the reason why we keep on searching different materials to make the cutting tool in order to reduce the cost of the tool, right? So please note down. मैं लिखूंगा नहीं, मैं डिक्टेट कर रहा हूं, आप लिखिए. Abrasive ceramics are used abrasive ceramics are used to cut comma wear, wear, wear or grind, to cut, wear or grind other material which necessarily is softer, which necessarily is softer. Which necessarily is softer. Abrasive ceramics are used to cut, grind or wear other material which necessarily is softer. Full stop. Therefore, 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 the prime requirement for this group of material, the prime requirement for this group of material therefore, the prime requirement for this group of material is hardness, is hardness, hardness or wear resistance, or wear resistance, or wear resistance, or wear resistance, कॉमा लगाएं. In addition, a high degree of toughness, in addition, a high degree of toughness, a high degree of toughness is essential, is essential to ensure that, to ensure that, is essential to ensure that the abrasive particles, to ensure that the abrasive particles abrasive particles to ensure that abrasive particles do not easily fracture, do not easily fracture, do not easily fracture, do not easily fracture. Full stop. Full stop. Furthermore, high temperatures, furthermore high temperatures may be produced from, may be produced from abrasive frictional forces, from abrasive frictional forces, abrasive frictional forces. So some refractoriness is also desirable. So some refractoriness is also desirable. So some refractoriness is also desirable. Full stop. Next point. Diamonds लिख लो. Diamonds are utilized as abrasives. Diamonds are utilized as abrasives. Are abrasives. However, they are relatively expensive. However, they are relatively expensive. They are relatively expensive. Full stop. The more common ceramic abrasives include the more common the more common abrasive ceramics include silicon carbide, silicon carbide, tungsten carbide, tungsten carbide, aluminum oxide, aluminum oxide, aluminum oxide, and silica sand, and silica sand, and silica sand. Full stop. Written. Shall we go ahead? And silica sand. These are very popular ceramics used as an abrasive. Let's go for next. In the very beginning, I told you few topics you have to study from the theory book. So from this chapter, you have to study from theory book. हालांकि questions has been negligible from those topics, but they may ask. So silicate स्ट्रक्चर मार्क कर ले, इन टॉपिक्स को लिख ले और इन्हें आपको पढ़ना होगा. Then second is glass. Glass is an amorphous material. कैसे बनता है? I have discussed in crystallography कि when sand is in the molten state and if it is rapidly cooled, then amorphous structure would be developed, and that is known as glass. And third one is carbon. Basically, carbon has three allotropes and they are diamond. So crystal structure of diamond we have discussed earlier, and then graphite and then fullerene. So please refer theory book for these three topics. रेफर थ्योरी बुक मैंने ही लिखा है, तो जो जरूरत है वो प्रॉपरली वहां पर लिख चुके हैं. एक तरह से वो आपके नोट्स हैं. सो एक बार एक रीडिंग दे दीजिएगा, कवर हो जाएगा. नॉट मोर देन दैट इज रिक्वायर्ड, बट ब्रीफली यू नीड टू स्टडी. पहले नोट्स पढ़ेंगे, नोट्स के बाद जब समय बचेगा, सो यू वुड बी गोइंग फॉर ऑल दिस. नाउ लेट अस मूव ऑन टू द नेक्स्ट चैप्टर. अब अगले चैप्टर की तरफ चलते हैं. Let's move on to the next chapter. That is polymers. Very important chapter. I would be giving you notes, but no are. In this chapter, if you observe, most of the questions are theoretical in nature. Generally, two questions will be asked from this chapter. One question would be on the basis of fundamental definitions and theories. That question you will be able to easily handle. But one question is generally asked from the name of the polymers, trade name of the polymers. That is very difficult to memorize. I have given you a list of the polymers in the theory book. So, if you can memorize, you will try to memorize. And that list is also not exhaustive. ये क्या हो गया? That list is also not exhaustive. It's not like that list contain the name of all the polymers. No. There may be some polymers which I don't know the name. Industry use lots of polymers, so it's not practically possible to remember the name of all the polymers. So I will say that try to know the few important polymers from the book which we have given, and if you get the name from those polymers, it's good. Your luck is favoring to do that question. But if you get some other polymer which you have never seen, never read, so try to skip that kind of polymers. So don't worry about those kind of questions. आप नहीं कर पाएंगे तो कोई नहीं कर पाएगा. But जो fundamental questions हैं उनको कर सकते हैं. So let us try to discuss fundamentals. Here, first of all, we have to discuss few terms. This polymer. The mer word is used for simple, it is used for repeat unit. I will be defining it properly, don't worry. And poly means many. So poly means many. Actually, before studying polymer, let us try to understand monomer. These are simple hydrocarbon molecules. Most of these monomers are simple hydrocarbon polymers. अभी कुछ लिखे ना, सुनते चले मुझे. Hydrocarbon means those materials which are mainly made of hydrogen and carbon. For example, CH4. This is a hydrocarbon. But this CH4 has all the bonds saturated. So it cannot be our monomer. ये हमारा monomer नहीं हो सकता. Basically, monomers are those simple molecules which can be used to make a larger molecular structure. So that kind of large molecular chain-like structure is known as polymers. Poly means many. So where many monomers come closer to each other to make a larger molecular structure, that molecular structure is known as polymer, right? Now you see here, since all the bonds are already saturated, there is no possibility of growing the chain. So this cannot be used as a monomer. But you see a different hydrocarbon, C, double bond C, H, H. If you see this hydrocarbon, you will find it. If you break this covalent bond, so one electron will be here and one will be here. So you can connect other molecule at this point and other molecule at this point. Double bond will be broken and it will become a single bond. So this will become a repeat unit. Such repeat unit is known as monomer, and such simple hydrocarbon molecules which can be used to make polymer, they are known as monomer. And the single repeat unit will be known as mer. So mer और monomer में different ये है कि monomer is the simple molecule used to make the polymer, and mer is the repeat unit which is again and again repeated in the whole structure of the polymer. So one important conclusion which we can withdraw is that every hydrocarbon molecule cannot be treated like a monomer. Instead, those hydrocarbon molecules which have multiple bond, they can be used to make the polymer, and hence they can be treated as monomer. It's not necessary that you should have only multiple bond. You can have functional group also, like this is benzene ring and this is OH. So this material is known as phenol. Here, because of this OH is known as functional group. So these positions 2, 4 and 6, these positions become very active to grow the chain. So such materials are also useful to make the polymer. So either you should have a multiple bond or you should have a functional group like OH, Cl, NH2 या NH3 whatever is that, NH2, CHO etc. कुछ भी हो सकता है, COOH. So these are the things which must be available. Then only you can say that your simple molecule can be used to make a polymer and you can say it as a monomer. राइट. सो चलिए ये डिफिनीशंस लिखते हैं. चैप्टर में लिखना बहुत ज़्यादा कुछ पड़ेगा. सो थ्योरेटिकल नेचर ऑफ चैप्टर है. मैं बोर्ड पर लिखने की बजाय आपको डिक्टेट करता रहूँगा, क्योंकि अगर मैं बहुत लिखूँगा तो बड़ा लेंदी हो जाएगा, बहुत समय लग जाएगा. सबसे पहले पॉलीमर डिफाइन करते हैं. पॉलीमर डिफाइन करें. अब क्योंकि ये हाइड्रोकार्बन है, सो दीज आर ऑर्गेनिक मटेरियल. कार्बन बेस्ड मटेरियल को हम लोग ऑर्गेनिक मटेरियल कहते हैं. लिखेंगे पॉलीमर्स आर कोवैलेंटली बॉन्डेड polymers are covalently bonded long chain molecules, long chain molecules, long chain molecules. Covalently bonded long chain molecules containing thousands of atoms, containing thousands of atoms, thousands of atoms. Containing thousands of atoms. Thousands of atom. Sometimes called as macro molecules. Macro मतलब large. Sometimes called as macromolecules. If molecular structure is very lengthy, then the material cannot be crystal, because if molecular structure is smaller, then periodic arrangement of atoms is possible. But if it is a very long molecular structure, then the atoms may not follow the periodicity, and this way these materials are amorphous material. ऐसे लिख लीजिए, most of them are amorphous materials. Right. नेक्स्ट पॉइंट लिखेंगे, मोस्ट ऑफ द पॉलीमर्स आर ऑर्गेनिक मटीरियल्स. मोस्ट ऑफ द पॉलीमर्स आर ऑर्गेनिक मटीरियल्स. ऑर्गेनिक मटीरियल्स. मोस्ट ऑफ द पॉलीमर्स आर ऑर्गेनिक मटीरियल्स. Next point. Next definition is monomer. Monomer. Next point is monomer. इसमें लिखेंगे The term monomer refers to the term monomer refers to the small molecule small molecule from which a polymer is synthesized, from which a polymer is synthesized, from which a polymer is synthesized. उसके बाद लिखें मर। देखो मोनोमर और मर का डिफरेंस समझिए। मर को हम लोग रिपीट यूनिट भी कहते हैं, इट इज आल्सो नोन एज रिपीट यूनिट। A very popular polymer is polyethylene. So let us try to write it. So we have a simple molecule of ethylene, C double bond C, H, 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 H. This is ethylene. When we use large number of ethylene molecules, so it will become polyethylene. Like this. H, 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 H. We can represent them like this. H, 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 H. So this is polyethylene. This is polyethylene. This simple molecule which is used to make the polyethylene is known as monomer. And this large molecular structure is known as polymer. In this you see each carbon atom is connected with covalent bond. That's why I said it is covalently bonded structure. So in a chain all these carbon atoms are connected with covalent bond. A single repeat unit, you see this is your repeat unit, again and again it is being repeated. So this single repeat unit, this is known as मर, इसे हम लोग मर कहते हैं. So the difference in मर and polymer is मर and monomer is simple molecule which is used to make the polymer, whereas मर is the single repeat unit. अब अगर आइडेंटिकल रिपीट यूनिट के थ्रू चेन की ग्रोथ हो रही है तो ऐसे पॉलीमर को होमोपॉलीमर कहेंगे. अभी लिखा दूंगा मैं, होमोपॉलीमर कहेंगे इफ द स्ट्रक्चर इज कंटेनिंग आइडेंटिकल, जैसे इस केस में है. लेकिन लेट अस सपोज मोर देन वन टाइप ऑफ मर आर पार्टिसिपेटिंग टू मेक द चेन. यहां पर ये है, सपोज यहां Cl हो जाता, सपोज यहां कुछ और हो जाता. सो इफ मोर देन वन टाइप ऑफ मर्स आर पार्टिसिपेटिंग इन द चेन देन दैट इज नोन एज कोपॉलीमर. तो उसे हम लोग नाम देंगे कोपॉलीमर. ठीक. सो दिस इज डिफरेंस बिटवीन मर, मोनोमर, होमोमर, होमोपॉलीमर, कोपॉलीमर एटसेट्रा. सो पहले मोनोमर आपने लिख लिया है, अब मर लिखिए. मर, मर में लिखिए these long polymers, long chain molecules लिखो. These long chain molecules are composed of, these long chain molecules are composed of structural entities, structural entities called mers, structural entities called mers, which are successively repeated, which are successively repeated along the chain, which are successively repeated along the chain, which are successively repeated along the chain. फुल स्टॉप। आगे लिखेंगे होमोपॉलीमर, होमोपॉलीमर। नेक्स्ट वन इज होमोपॉलीमर। इसमें लिखेंगे when all the repeating units along a chain, when all the repeating units along the chain, along the chain are of the same type, are of the same type, are of the same type, the resulting polymer is called as homopolymer. The resulting polymer is called as homopolymer, homopolymer, homopolymer. Full stop. Next heading copolymers, copolymers. If chains are composed of, if chains are composed of two or more different repeat units, if chains are composed of two or more different repeat units, if chains are composed of two or more different repeat units, then polymer is called copolymer, then polymer is called copolymer. Next, next is functionality. Basically, this is how many active sites are available to grow the chain. For example, C double bond C, H, 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 H. So if you break the bond, so it will become C, C, H, 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 H. So now you have two active sites, one electron here and one here. So this is having two active sites. So this monomer has functionality 2. So basically functionality is number of active sites from where chain can be grown. So जितने भी डबल बॉन्ड के कंपाउंड्स होंगे all of them are having functionality equal to 2. लेकिन लेट अस सपोज मैं इसकी बात कर रहा हूँ, फिनॉल की बात कर रहा हूँ, सपोज लाइक दिस. So in phenol, basically you start numbering like this 1, 2, 3, 4, 5, 6. So these three positions 2, 4 and 6, these three are active sites. So 3 active sites, and if it has 3 active sites, then the functionality is 3. So how many active centers or sites are available to grow the chain? that is known as functionality of the molecule. So define करेंगे पहले इसे. Functionality is defined as functionality is defined as functionality is defined as defined as the number of bonding sites, the number of bonding sites the number of bonding sites present in the molecule of monomer, present in the molecule of monomer, present in the molecule of monomer. Monomer, full stop. For example, ये एग्जाम्पल लिख करके ऐसे लिखे, all double bonded compounds, all double bonded compounds, for example, all double bonded compounds have two bonding sites, have two bonding sites. So their functionality is 2. So their functionality is 2. So their functionality is 2. Their functionality is 2. आगे देख. Whereas in phenol, there are 3 active centers. Whereas in phenol there are 3 active centers. So functionality is 3. So functionality is 3. बहुत ही theoretical topic है, तो थोड़ा सा पेशेंस के साथ पढ़ते चलिए. So functionality is 3. Next, next is polymerization process. Polymerization process. This is a chemical reaction in which monomer converts into polymer. And in order to happen this reaction, we have to create certain conditions. हमें टेम्परेचर बढ़ाना पड़ सकता है, प्रेशर बढ़ाना पड़ सकता है, whatever is the demand of the reaction, that kind of circumstances we need to create, and this way monomers will get converted into the polymers by this reaction. So the reaction which takes place for the conversion of monomers into polymers, that is known as polymerization. So please note down. Polymerization is the chemical reaction. Polymerization is the chemical reaction through which through which monomers are joined, to make large molecular structure, that is polymer, to make large molecular structure, that is polymer. अभी पॉलीमराइजेशन के बारे में आगे डिटेल में बात करेंगे, अभी छोड़ देते हैं, अभी कुछ और डेफिनेशन. डिग्री ऑफ पॉलीमराइजेशन, डिग्री ऑफ पॉलीमराइजेशन यानी कितने सिंपल मॉलिक्यूल्स मिल करके पॉलीमर बना रहे हैं. So how many number of simple molecules are coming together to make the polymer? So the best way to calculate this number is to calculate the molecular weight of polymer and divide it by the molecular weight of monomer. So DOP, that is degree of polymerization, can be mathematically defined as MP upon mm, that is molecular weight of polymer, molecular weight of polymer divided by molecular weight of monomer, molecular weight of monomer, molecular weight of polymer divided by the molecular weight of monomer. This is defined as DOP, degree of polymerization. लिख लीजिए. Quickly do it. कुछ नहीं. कल वाले सारे वीडियो अपलोड हो गए? कल वाले सारे हो गए? अच्छा.
एक्चुअली सर इसके पास एक क्लासरूम वाला जो लड़का था ना सिविल का, उसका वीडियो आ गया और सर ने बोला 11 बजे पहले उसको
करो कोई नहीं.
तो करवाएंगे.
I, degree of polymerization. Next we would be trying to know molecular structure of polymers. Molecular structure of polymers. Molecular structure of polymers. First, linear chain polymers या linear polymers. Linear polymers. You see, my dear friend, in these polymers, the chain structure is linear. Means the carbon atoms are linearly connected with each other like this. There is no branch. So these carbon atoms are connected with each other in the linear fashion. So there are no branches formed in the polymer like this. You see, each of them are a single chain. So like this. This kind of molecular structure, this kind of polymer which has linear structure, there are no side branches, only a single chain is there. These polymers are known as linear polymers. So इसमें लिखेंगे प्लीज नोट डाउन. डिक्टेट ही करता रहूं कि लिखूं? मैं डिक्टेट करता रहूं क्योंकि लिखने में बहुत समय लग जाएगा और डिफिनीशंस हैं और डायरेक्ट ही पूछी जाती हैं. जैसे इसमें अभी एक पढ़ाऊंगा ब्रांच पॉलीमर, लीनियर और ब्रांच पॉलीमर दोनों की डिफिनीशन पूछी जा चुकी है. सो एक एक लाइन में लिखते चलें. लिखेंगे लीनियर पॉलीमर्स linear polymers, linear polymers are those are those linear polymers are those in which the repeat units are joined together are joined together end to end in chains, in a chain लिख लो, end to end in a chain, end to end in a chain. अब एक जो बड़ी बात ध्यान देने वाली होगी कि in a chain two carbon atoms are connected with covalent bond, but chain to chain, since there is no branch, so how they can be connected? These chains can be connected through secondary force. Secondary force means van der Waals bond. So interchain coupling in these linear polymers is possible through van der Waals bond या van der Waals force. And that is the reason these are very weak materials, because as soon as you apply stress, these van der Waals forces are weaker, so दो चेन के बीच से मटेरियल ब्रेक कर जाएगा. सो एक बार क्वेश्चन पूछा गया कि पॉलीमर्स आर वीकर देन द मेटल्स एंड सेरेमिक्स, असर्शन में लिखा उसने, और रीजन में लिखा कि बिकॉज चेन्स आर कनेक्टेड थ्रू द वैन डर वाल फोर्सेस. आंसर इज करेक्ट, बोथ आर करेक्ट एंड एक्सप्लेनेशन इज आल्सो करेक्ट, यानी आंसर इज ऑप्शन ए. Why? Because these forces are very weak. So, and in metals and ceramics, there are all the primary bonds in 3D. So, primary bonds are stronger than the secondary bond. It means primary bonded material would be stronger than the secondary bonded material, and that is the reason why these materials are not that much strong as the metals या ceramics. But यहाँ एक चीज cautious रहने की जरूरत है. As a whole, bulk material में secondary bond is decreasing its strength. But if I talk with a single chain, कि कोई एक chain निकाल लिया, so in a single chain there is no van der Waals force. In a single chain there are only carbon carbon covalent bonds. So single chain withdrawn from these polymers is very strong, because carbon carbon covalent bond is very strong. Such single chains are thin hair like structures, and such thin hair like structures are known as fibers. So bulk polymer is weaker, but when you withdraw a fiber from the polymer, it is a very strong material. So you should be knowing this fact कि कैसे fiber strong है, because carbon carbon covalent bond that is very strong. लेकिन bulk polymer इसलिए weaker है कि interchain coupling is through very weak force, and that weak force is van der Waals force, which is decreasing the strength of overall product. So एक line लिख लीजिए. For linear polymers, there may be extensive there may be extensive there may be extensive van der Waals bonding van der Waals bonding between the chains. There may be extensive van der Waals bonding between the chains. Between the chains. ठीक है, नेक्स्ट चलते हैं. सेकेंड वन, branched polymers. Here you see, my dear friend, there is a single chain. This is the main chain. So in this main chain, carbon atoms are connected like this, like this. So this one is main chain. But along with the main chain, you can have some side chains also, like this, like this, like this. So these are the side chain, and these side chains are known as branches. So such kind of polymer is known as branched polymer. So in branched polymer, branches या side chains are connected to the main chains. So there is a huge difference. Here only a single chain is there, but here in the chains there are branches also. Please note down. Polymers in which side branch chains are connected are connected are connected to the main ones to the main ones to the main ones are called branched polymers are called branched polymers. What is the big advantage of branch advantage या disadvantage कुछ भी कह सकते हो. If there are linear chains, packing efficiency would be high. But if branches are there, then these branches will not allow to be a very high packing efficiency. So in the branched polymers, packing efficiency will reduce as comparison to the linear polymers. So लिख लेते हैं. Definition मैंने branch polymer की बोली कि polymers in which side branch chains are connected to the main ones are called branched polymers. फुल स्टॉप. इसमें लिखेंगे द चेन पैकिंग इफिशियंसी इज रिड्यूस्ड द चेन पैकिंग इफिशियंसी इज रिड्यूस्ड द चेन पैकिंग इफिशियंसी is reduced with the formation of side branches with the formation of side branches with the formation of side branches which results in lowering of the polymer density which results in lowering of the polymer density which results in lowering of the polymer density. Lowering of the polymer density. पॉलीएथिलीन जो होता है ये दो तरह से होता है. जब लीनियर चेन पॉलीएथिलीन बनता है तो पैकिंग इफिशियंसी बहुत होती है और वो HDPE कहलाता है. लेकिन जब ब्रांच चेन पॉलीएथिलीन बनता है तो पैकिंग इफिशियंसी लो होती है और वो LDPE कहलाता है. सो हाई डेंसिटी polyethylene. This is linear chain structure. This is linear polymer. And low density polyethylene, low density polyethylene. This is branched polymer. Branched polymer. This is branched polymer. ठीक है. So this is about the branched polymer. Done? Shall we go ahead? आइए थर्ड आते हैं. Third one is cross-link polymer. Third is cross-linked polymer. देखो, suppose you have a branched structure. You have a branch structure like this. So these are the main chains. Main chain. These dots are showing carbon atoms in the chain. Hydrogen need not to represent. That is understood. To satisfy the valency of carbon, how many hydrogens are required, you can put them. Now, suppose these are connected, the branches connect with each other. So, this is known as cross-link polymer. If they are connecting each other, then that is known as cross-link polymer. Such polymers are known as cross-link polymers. Sir, the carry bag we use in grocery shop etc., that polyethylene is which one of these? Beta, generally the polythene which we use carry bag etc., that is low density polyethylene. High density polyethelenes will be stronger one. So जहाँ थोड़ा सा strong material आप बना रहे हैं polyethylene से, जिसकी strength high है, बोतल वगैरह, they can be the high density. बट आपसे इस तरह के क्वेश्चन नहीं पूछे जाएंगे. लिखेंगे जरा. इन क्रॉस-लिंक्ड पॉलीमर्स, in cross-linked polymers, in cross-linked polymers, in cross-linked polymers, adjacent linear chains are joined. Adjacent linear chains are joined. Adjacent linear chains are joined to one another, joined one to another at various positions by covalent bonds. At various positions by covalent bonds. So they are joined at various positions by covalent bonds. This is the definition of cross-linked polymer. Please note it down. Done? Good. Last one, network polymer. Fourth one is network polymer. ये जनरली हमारे पास जो फंक्शनल ग्रुप से बने हुए पॉलीमर्स हैं, जैसे ये है, जिनमें मोर देन वन एक्टिव साइट्स होंगी, सॉरी मोर देन टू एक्टिव साइट्स होंगी, वो 3D में क्रॉस लिंकिंग करेंगे लाइक दिस, क्योंकि दे हैव मल्टीपल एक्टिव साइट्स, so they may be doing cross linking in 3D. So such polymers are known as network polymers. Like this, बना लीजिए. Every point is representing a carbon atom. Like this. These are the carbon atoms. All of them are carbon atoms. So you can write it like this कि multifunctional monomers, जैसे जो मल्टीपल बॉन्ड है, डबल बॉन्ड है, उसकी फंक्शनैलिटी दो है, उनमें से आप अभी रिएक्शन के दौरान देखेंगे कि एक साइड ब्लॉक हो जाती है एंड चेन ग्रोज ओनली एट वन पॉइंट, बट जो मल्टीपल फंक्शनल ग्रुप्स हैं उसमें अगर एक ब्लॉक भी हो गया तो भी मोर देन टू साइड्स आर अवेलेबल, सो दे मेक कनेक्शन इन 3D एट वेरियस प्लेसेस, सो दे मेक अ नेटवर्क. Nishtha is asking, sir, cross-link polymers will be stronger than linear polymers. Yes, obviously, because in cross-linking, van der Waals force is removed. Now we are having the connection between the chains with the primary bond, and primary bond is stronger than the van der Waals. So cross-link polymers, या network polymer, all these will be stronger than the linear polymers. लिखेंगे यहाँ पर multifunctional monomers, multifunctional monomers, multifunctional monomers forming 3 or more active covalent bonds, forming 3 or more active covalent bonds, active covalent bonds, forming 3 or more active covalent bonds, make three-dimensional network, make three-dimensional network, make three-dimensional network, and are termed as network polymers, network polymers, and are termed as network polymers. लिख लीजिए. ठीक है. Done. Good. Next, molecular configurations of polymers. Molecular configurations of polymers. Molecular configurations of polymers. Consider a repeat unit. Consider a repeat unit, जिसे हम लोग क्या कहते हैं, मर. Let us suppose this is our repeat unit, C, C, H, H. अच्छा, ये मैं जो चेन ऐसे C, C बनाता हूँ, H ऐसे, this is actually 2D representation. In reality, carbon has a bond of 109 degree. So the chain is something like this. ये इस तरह से chain होती है, ये bond angle 109, then like this. So something like this kind of structure is there. And one hydrogen atom is at this side, then another is at this side, like this. So bond angle should be 109 degree. इस तरह का structure होता है, but the general representation is something like this in 2D. We do leave it. So C, H, 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 and R. Let us suppose this is R. This R can be anything. It is OH, it is Cl, it is COH, it is NH2, it is CHO, etc. कुछ भी हो सकता है. So it should be anything other than hydrogen. This R represents an atom or side group other than hydrogen. R represents atom or side group other than हाइड्रोजन. हाइड्रोजन के अलावा जो एटम या साइड ग्रुप होगा उसे आर से डिनोट करते हैं. Now this R is connected at some point, so this carbon atom will be known as head and this side would be known as tail. This is the way to represent a mer. So this part is known as head. जिस carbon से R connected होगा that is known as head, and the other back side जो carbon है that will be known as tail. Now we can have some possible configurations for the polymer molecule. So one configuration is C, 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 like this. So suppose it is H, it is H, it is R, it is H, then it is H, this is H, this is R, this is H, this is H, this is H, this is R, and H. This is one configuration. The other configuration can be looking like this: C, 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 C. So it can be something like this: H, H, R, H, R, H, 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 R, H, R, H, like that. बढ़ते चले जाएंगे. H, H, like this. So we can have these two types of configurations. You see, in the first configuration, head is connected with tail. So this configuration is known as head to tail configuration, head tail like this. But here head is connected with head. So this is known as head to head configuration, right? So we can write these configuration, the naming of these two configurations. The first one is known as head to tail configuration. This is known as head to tail configuration. And this is known as head to head configuration. Head to head configuration. So you are having two types of molecular configuration in the chain. Please note down. Someone is saying, will you please show the definition of cross-linked polymer just for 3 seconds? Yes, I will show. First you write this. Done? किसी ने क्रॉस लिंक की डिफिनीशन शो करने के लिए कहा था फॉर 30 सेकंड. प्लीज डू इट क्विकली. Yes, Manjeet, you are right. Based on these configurations, we used to write IUPAC names. बट इतना डेप्थ में हमें केमिस्ट्री में नहीं जाना है. मैं उम्मीद करता हूँ कि शायद वो इतना तो ना पूछें. बट बेसिक्स दे में आस्क, सो आई एम वांटिंग टू कवर दोज बेसिक्स. नेक्स्ट इज आइसोमेरिज्म. Isomerism. Let me define it first. What is isomerism? Isomerism is defined as ये जो हाइड्रोकार्बन कंपाउंड्स हैं, दे विल हैव सेम केमिकल फार्मूला बट देयर geometrical orientation या arrangement can be different. This phenomena is known as isomerism. So hydrocarbon compounds, hydrocarbon means the compounds which are composed of hydrogen and carbon. Hydrocarbon compounds with the same hydrocarbon compounds with the same composition may have different hydrocarbon compounds with the same composition may have different atomic arrangements. This phenomena is known as, or termed as, phenomena is termed as isomerism. Let me give you an example. Butane is this C, 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 and connect hydrogen atoms to satisfy the valency H, 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 H. This is normal butane. This is normal butane. But you can write it like this also, C, 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 H, 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 C, H, H, H. This is isobutane. So, you see the atomic arrangement is different, but you have same chemical formula, 4 carbon atoms and remaining hydrogen, and similarly 4 carbon atoms and remaining hydrogen. But geometrical orientation of the atoms is different. So, this phenomena is known as isomerism, and these two isomers will have different properties, because the molecular structure will define how they are getting packed, and according to that what would be the density, what would be melting temperature, everything would be designed according to their molecular structure. So, if the molecular structure is changing, their geometrical arrangement is changing, then their properties will also change. So, isomers will have different properties. This butane and this butane will have different properties. Please quickly note it down. Next, stereoisomerism. 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 ऐसे समझें, उसके बाद लिखिए, पहले समझें. लेट अस सपोज ये सी, सी, एच, ये आर ग्रुप है आपका, एंड एच, एच, ये एक मर है, एक रिपीट यूनिट है. सो ऑल द मर्स आर कनेक्टेड हेड टू टेल, सेम फैशन में दे आर कनेक्टेड हेड टू टेल. बट जब ये हेड टू टेल, ऑल द कार्बन एटम्स हैव 4 बॉन्ड. मैंने ज्यादा बना दिए क्या? एक एच यहां बना लो. Whenever I miss any bond, you can put H atom, right? Hydrogen is there to satisfy the valency. Every carbon atom has 4 valency, so that valency 4 is satisfied. You can write like this. चलिए, आइए. So what I am saying कि all the mers in the chain are connected head to tail, but जो active group है, R group है, this may be having 2 configuration. In one configuration, it can be at the same side of the chain, and in other configuration, it may alternate the side of the chain. This phenomena is known as stereoisomerism. देखते हैं, बना करके देखते हैं, ज़्यादा समझ में आएगा. So you see, all the R are in the same side. Like this. You see, the connection is head to tail, head to tail, head to tail, but all the R groups are at the same side. Similarly, if you go, we can have this kind of connection, C, C, H, H, and this is R, and H, C, H, H C R H C H H C and H H R. Now here you see again head to tail, head to tail, head to tail, but R groups alternate at the side of the chain. This is the main chain and they are alternatively here, then here, then here, then here, like this. So this phenomena is known as stereoisomerism. Please note down stereoisomerism first, then these examples. Stereoisomerism denotes the situation. Stereoisomerism denotes the situation. Stereoisomerism denotes the situation in which atoms are linked, in which atoms are linked, atoms are linked, atoms are linked together in the same order, together in the same order. Within bracket you can write head to tail, in the same order, head to tail, but differ in their spatial arrangement, but differ in their spatial arrangement, but differ in their spatial arrangement. For one isomerism, stereoisomerism, for one stereoisomer, stereoisomer, all the R groups are situated, all the R groups are situated at the same side of the chain, at the same side of the chain, at the same side of the chain. Whereas for other stereoisomer, for other stereoisomer, R groups alternate both sides of the chain, both sides of the chain. Alternate का मतलब एक बार इधर फिर इधर फिर इधर फिर इधर, like this. This configuration where all the R atoms are same side, this is called as isotactic configuration. This is called as isotactic configuration, isotactic configuration. And this where R groups are alternating, this is called syndiotactic configuration. This is called syndiotic configuration. This is called syndiotic configuration. Please note it down. ये लिख लें. Stereoisomerism. Do it. हाँ, थ्योरी बुक में कुछ चीजें नहीं हैं, इसीलिए नोट्स में कराना पड़ रहा है. एवरीथिंग इज नॉट इन थ्योरी बुक. Written. Please note down quickly. There is one more possibility available. What is that possibility? Let us suppose this is chain H, H, R. You get head to tail R, but two R are this side and one at this side. Let us suppose. Then again head to tail, and then again you see R here. What my point is, random positioning is there. है तो दोनों तरफ, but you cannot say with the guarantee कि they are alternating. First two, then second, then one, then again it may go like this. So it may be like this. So they are not like this. Here every time it is alternating. Here random positioning of R atoms is happening. So if random positioning is happening, it is known as atactic configuration. So for random positioning, the term atactic configuration is used. For random positioning, the term atactic configuration is used. Atactic configuration is used. For random positioning, the term atactic configuration is used. लिख लीजिए. प्रवीण सक्सेना जी पूछ रहे हैं कि मिस्टर हाफ क्लास व्हाट वुड बी टुमारोज टाइम. Tomorrow I need only 3 hours to complete. So 9 a.m. to 12 a 12 को तो am क्या ही लिखेंगे, 12 noon. So 9 to 12. Tomorrow class timing would be 9 to 12. Class timing 9 से 12 रहेगी. Only 3 hours are required to complete tomorrow. चलिए. I need to define one more type of isomerism if you have written it. Next one is geometrical isomerism. Next is geometrical isomerism. It will take place in only those polymers जहां पर mers are having multiple bond. यानी मर में कोई एक multiple bond है. For example, this one. C double bond C, then C, then C. So there is a double bond in mer, and it is having something like this kind of structure. Here H, here H, here H, right? And here let us suppose you have a CH3, here you have H, so bond is completed, H, H, H. One structure can be like this, where CH3 and CH3 is basically R and H, both are at the same site. There can be one more structure. In that structure, we have like this C, C, double bond C, C, right? So let us suppose CH3 is here and H is here. So they are at the opposite side of the double bond, here and here. In this case, both were the same side of the double bond. Here they are at the opposite side of the double bond. Remaining are H connected as it is. H connected as it is. Right. So this phenomena is known as geometrical isomerism, and this structure is known as cis structure. Cis structure, and this structure is known as trans structure. Trans structure. So before writing it, let us first define geometrical isomerism. Then you can write cis and trans. Geometrical isomers are possible. Geometrical isomers are possible. Are possible. Geometrical isomers are possible within repeat units. Within repeat units. Repeat units. Having a double bond. Having a double bond between chain carbon atoms. Repeat units having a double bond between chain carbon atoms. Chain carbon atoms, having double bond between chain carbon atoms. ठीक, यहाँ दो तरह के स्ट्रक्चर हमारे पास पॉसिबल हैं. सिस स्ट्रक्चर, CH3 and H groups are lying at the same site of the double bond. CH3 and H are on the same side of double bond. Then it is known as cis structure. CH3 and H are CH3 and H are on the opposite side of double bond. So it is trans. Please note down it quickly. कहाँ एक एच ज्यादा हो गया भाई, किसी ने कहा कौन सा एच ज्यादा हो गया? 2 2 4 ठीक है, 2 2 4 ठीक है, 2 2 4 ठीक, सब तो 4 4 ही है। 2 2 4 ठीक, इसके लिए भी 4 ठीक, एवरीथिंग इज करेक्ट। कहाँ आपको एच ज्यादा लग रहा है, किसने लिखा है? अनूप मलिक, वेयर इज मोर एच? इट्स गुड। आइए, सो दिस वाज अबाउट द, नहीं, others it is not necessary CH3, it can be anything other than H, ठीक है। so that is basically R, मल्टीपल बॉन्ड के चारों तरफ R होना चाहिए, R can be anything other than H। let's go for the other things। इस चैप्टर में कुछ और भी जरूरी बातें हैं। लास्ट वाले में एक H ज्यादा है तो कम कर लो, मुझे तो नहीं ज्यादा दिख रहा, कहाँ ज्यादा है? 4 बॉन्ड्स ठीक है, 4 बॉन्ड्स 2 3 4 ठीक है। अच्छा दिस, ये वाला हटा दो, गुड, ओके, रिमूव दिस, 2 3 4, हाँ 4 बॉन्ड्स, रिमूव दैट। CH3 and H should be at the opposite side, remove this one, okay, thank you। let's go for the next types of polymerization, types of polymerization, important है, you will be getting several time questions from this। there are two types of polymerization reaction, there are two types of polymerization process। first, addition polymerization, addition polymerization, it is also known as free radical polymerization, it is also known as chain reaction। second one is condensation polymerization, condensation polymerization, it is known as step reaction। these are the two broad types of polymerization reactions, please note down। carbon can never have 5 bonds, five bonds, can never have 5 bonds, it will have always 4 bonds only। so गलती से हो गया था। Alok Nathani has asked, sir, does these polymers contribute in enhancing tensile strength has been used? Yes, if you withdraw fiber from the polymer, polymer bulk material does not have good strength. But as I told you, single chain of polymers, that is known as fiber, that is a very strong material and that has very high tensile strength. So if you use that fiber of the polymer for the reinforcement in other material, then that may increase the tensile strength. And this is the reason why I discussed at that point ki bulk polymer is not stronger, but the fiber of the polymer is very strong, because fiber does not have any kind of van der Waals force. It is a linear structure, basically single chain. आगे बढ़े. Good. So let us start discussing addition polymerization. First one is addition polymerization. Very important. Polymers formed with this reaction will be known as addition polymers, addition polymerization, या free radical polymerization. Here all the monomers will add with each other to make the larger structure, as the name is suggesting. So all the monomers will get added to each other and hence a polymer is formed by the simple addition of all the monomers. There will not be any byproduct, कोई भी byproduct या wastage नहीं होगा. जितने भी मोनोमर्स होंगे वो सारे के सारे मिल करके सिर्फ पॉलीमर बनाएंगे. दिस इज द बेस्ट वे टू आइडेंटिफाई द रिएक्शन, क्योंकि जो दूसरी रिएक्शन होगी उसमें मेन मटेरियल जो आप बनाना चाहते हो उसके अलावा एक बाई प्रोडक्ट भी बनेगा. बाई प्रोडक्ट इज अ काइंड ऑफ वेस्टेज. यू डोंट वांट टू वेस्ट योर मटेरियल व्हिच यू आर यूजिंग, बट दैट इज द ड्रॉबैक ऑफ द अदर रिएक्शन कि वहां पर कुछ ना कुछ वेस्टेज या बाई प्रोडक्ट जरूर बनेगा. बट इन द एडिशन पॉलीमराइजेशन देयर इज नो वेस्टेज और बाई प्रोडक्ट. सो पहले रिएक्शन को लिख लेते हैं और इसकी डिफिनीशन को लिख लेते हैं एडिशन पॉलीमर की, एंड देन वी वुड बी डिस्कसिंग इन डेप्थ अबाउट दिस रिएक्शन. सो लिखें जरा. अ पॉलीमर फॉर्म्ड बाय द, मैं डिक्टेट कर रहा हूं, लिखें. अ पॉलीमर फॉर्म्ड बाय द direct addition of a polymer formed by the direct addition of repeated monomers without direct addition of repeated monomers without elimination of byproduct, without elimination of byproduct is termed as addition polymer, is termed as addition polymer, and the reaction is known as addition polymerization, and the reaction is known as addition polymerization. The reaction is known as addition polymerization. Full stop. The addition polymerization, follows through three steps. First, initiation. Second, propagation. Third, termination. The reaction follows through three steps: initiation, propagation, and termination. Addition polymerization reaction follows through three steps. These are initiation, propagation, and termination. One very important point which need to be observed here: I am saying that कि the monomers will be added to make the polymer. ऐसा नहीं है कि आपने ला करके एक बाल्टी में या एक बर्तन में तमाम सारे मोनोमर रखे और थोड़ी देर बाद लौट के आए और रिएक्शन हो गई और आपको पॉलीमर मिल जाएगा. इट्स नॉट लाइक दैट. We have to create certain condition to start the reaction, and that condition can be high temperature, high pressure, like that kind of condition. So whatever would be the demand of reaction that we have to create. Along with this, in order to start the reaction, we have to add some chemical initiator. Chemical initiators are basically highly reactive materials. For example, you add H2O2. This is peroxide. It is highly unstable. You heat it. ये heat करने का symbol है. So it will convert in H2O plus O star. I am not interested in H2O. This O star has single electron and it is known as free radical. This O is highly unstable. So this free radical will try to react with the monomers because it is highly unstable. So in order to achieve the stability, it will try to react with the monomers, and this way the reaction will start. It's not like always we need to add peroxide. We can add perchloride. There are several other types of the initiators which can be used. So in general, I can say that we can use any chemical initiator RR, and this will give us a free radical R star. We are not bothering कि इसके साथ बाई प्रोडक्ट क्या बनेगा, H2O बनेगा, HCl बनेगा. That's not desired for us. So first step is addition of the free radical to start the chemical reaction. So one by one हर स्टेप को देखते हैं. पहला स्टेप इनिशिएशन. एक एग्जाम्पल लेकर के देखा जाए. So we are adding R. इसको हीट दे रहे हैं थोड़ा सा. इट इज मेकिंग R स्टार. दिस R स्टार इज फ्री रेडिकल and it is chemical initiator. It should be added in very small amount just to start the reaction because it is a kind of impurity which would be available in the final product. So it should be in very small amount. This R star, which is a free radical, this will react with monomer. Let us suppose our monomer is ethylene. So it will react with ethylene. Ethylene is monomer. It is a monomer, right? This will break this bond. When this double bond is broken, one electron is available with this carbon and one with this carbon. So this R star will make a bond. एक electron इसका और एक इसका share करके एक bond बना लेंगे. So it will be having something like this kind of rest. RC. ये दोनों बॉन्ड बनाए. ये H as it is रहेगा. ये डबल बॉन्ड टूट करके सिंगल बॉन्ड. ये H एंड ये H, लेकिन एक फ्री इलेक्ट्रॉन इस कार्बन एटम के पास बचा रह जाएगा. दिस इज नोन एज मोनोमर फ्री रेडिकल. अब आपका मोनोमर ही फ्री रेडिकल बन गया. मोनोमर फ्री radical. So this is the first step where the reaction has started. So your monomer has now become active. So this monomer will start reacting with other monomers. So reaction will start to propagate. So the second step is propagation. Second step आपका propagation है. So in the second step you are having R, C, C, H, 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 H स्टार, ठीक, प्लस C, C डबल बॉन्ड H, 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 H. ये डबल बॉन्ड टूट जाएगा एंड यू वुड बी हैविंग, ये डबल बॉन्ड टूट करके ये कार्बन इसके साथ जुड़ जाएगा. R, C, 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 H, 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 right. This will connect with this H, H, C, H, H and star. This is known as dimer free radical. इसे हम लोग नाम देंगे डाइमर फ्री रेडिकल. डाइमर फ्री रेडिकल. Now it will connect with other trimer, quadmer, and this way the reaction will keep on propagating. So ये reaction इसी तरह से बढ़ती चली जाएगी. You would be having R C H H C H H C H H C H H C H H C H H star and like that. Now we want to terminate the reaction. अब हम reaction को बंद करना चाहते हैं. So one way to terminate the reaction is कि जैसे आपने initiator ऐड किया था वैसे terminator ऐड कर दो, कोई एक other material जो इसके साथ react करके इस active point को खत्म कर दे, reaction stop हो जाएगी. But the other way is कि don't add anything, just wait. It's not like that कि only one chain has started. Multiple chain has started to form. मैं अगर इसे लिखना चाहूं तो मैं लिख सकता हूं कि 3 मोनोमर मिल करके बने हैं. So इसी तरह से if n monomers are there, so the length of the chain would be n. So termination can happen by the coupling also. So you can write this termination. Let us suppose you are having two chains. One chain is like this, R, C, C, H, 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 and lots of M groups are connected. So C, 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 like M groups are connected in the chain. Plus R, C, C, H, 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 and star. Here N groups are connected. So one's active center is this, one active center is this. These are two different chains. So there is a possibility that these chains will couple with each other. So when these chains couple each other, the structure would be looking like this. This R, C, H, H, C, H, H, M. This will get connected with this C, C, H, 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 R, N. And this way you got a polymer of chain M plus N. This is your polyethylene. Here you see only polymer has been formed. The structure of polymer would be looking like the C, 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 like this, and H, 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 like this. This is your formed polymer. You are not getting any other material. There is no wastage, there is no byproduct. All the monomers has coupled to make the polymer. That is the beauty of addition polymerization reaction. One very important thing which you need to observe here, the reaction is propagating with the help of free radical, and free radicals are highly unstable. So if they are highly unstable, the reaction would be very fast. So it is very fast process to make the polymer. Here you see one more important observation, that is in each step there is only one active point at which chain can grow. Although a double bond has two active points, but one active point has been blocked by the initiator. So there is only one active point at which chain can grow. So since chain can grow only at one active point, so you will always get a linear chain structure. There is no chance of polymer having branch structure, because for the branch the chain should be growing at least at two places. Here the chain would be growing only at one place, so always you are going to get linear polymer structure. You have only one active center, so linear polymer structure like this. This kind of polymers you are going to get. If the chains are connected with the, if the chains are linear, then obviously they would be connected with van der Waals force. Within a chain, two carbon atoms are connected with covalent bond, but chain to chain coupling is through van der Waals bond. Van der Waals forces are very weak, so these materials are very weak. But they will give you one beautiful property. When you heat them, this material you heated, आपने इसका कुछ बनाया, इस material को use किया, now you are heating it. So when you heat, first of all these forces will get finished because these are the weakest one. So as you increase the temperature, these will get finished. As soon as van der Waals forces are finished, these chains are free and now they will start moving on each other. So on increasing the temperature, van der Waals force खत्म हो जाएगा, जिसके कारण chains एक दूसरे पर slide करने लगेंगे. And because of sliding of the chain, this material will have a rubbery liquid like structure. एक viscous liquid बन जाएगा. Now that viscous liquid can be easily converted into the desired shape, and if you cool down it will regain that shape. So these materials can be plastically deformed by heating them. Such materials which can be plastically deformed, which can be reshaped, recycled again and again by heating them, they are known as thermoplastic material. So addition polymers are resulting into the thermoplastic material. Thermoplastic materials are those plastic materials on heating which become a soft liquid and can be converted into the shape. On cooling they regain that shape. So n number of time they can be reshaped and recycled. So these polymers are very good for the recycling purpose. Actually polymers are having a big problem. They are non-biodegradable material. So their disposal is a big problem and they are one of the biggest environment pollutant. इन्हें ना आप पानी में फेंक करके गला सकते हो. If you are trying to sink them in the sea, so they will finish the ecosystem of sea, they will disturb the ecosystem of sea. अगर आप इन्हें लैंड पर पुट कर दोगे, so हजारों वर्षों तक they will be available on the land and that land will become barren land. अगर आप इनको ये कोशिश कर रहे हो कि जला करके खत्म करो, so when you try to burn them, they are carbon based, sulfur based, nitrogen based compounds, so they emit very poisonous gases and those are very hazardous for the health of the living being. So they cannot be finished, they cannot be destroyed, their degradation is very big problem. So the best way to protect the environment is कि जितना भी पॉलीमर बन गया उतना ही रहे, आप कोई नया पॉलीमर environment में लेकर के ना आओ. So for this purpose, recycling of the plastic should be promoted and thermoplastic materials on heating can be easily converted into the desired shape. So they are best for the recycling purpose. But sometimes there can be one question कि why recycling of plastics is not very popular. आप अपने घर से बाहर निकलिए, 1 किलोमीटर वॉक करेंगे, you will get lots of plastic materials here and there on the roadside. So it is not properly recycled. Whereas you see, you will not get even a single piece of metal. They are easily recycled because they are precious one. So why the recycling of polymers plastics is not very popular? There are few reasons. First, you should understand why we need to do recycling, because these are one of the biggest environment pollutant. They are hazardous for our health. So we need to recycle them compulsorily. But why recycling is not very popular? The first reason is the raw material which is required to make the fresh plastic, like this ethylene, propylene, butadiene, etc. They are the byproduct of petroleum. जब क्रूड ऑयल का फ्रैक्शनल डिस्टिलेशन किया जाता है, तो along with the main product we get some byproduct. Those are ethylene, propylene, butadiene, etc. So for that industry they are wastage. So they sell it with very low cost. So but for this industry they are the raw material. So raw material for the production of polymers is very cheap, and hence fresh polymers can be produced very nominal cost. So the production of fresh polymers is cost wise very effective. That is not a very costly affair because the raw material is cheaper. Now let us suppose we talk about scrap politics, scrap plastic. Scrap plastic means recycled product. So if you are wanting to recycle it, what will happen? You will sell it to the here and there in the city and then recollect it from there, and then you will be putting it into the factory to recycle it. These plastics are low density material, so they acquire large volume for their transportation. For example, आप अगर 10 metric ton metal या iron को transport करना चाहें one city to another city, so maybe you would be using one truck or one wagon of goods train. That would be sufficient. But to transport the same amount of the plastic, you would be requiring 2 truck, 3 truck like this, because they acquire larger volume. So because of their low density, their shipment cost, their transportation cost is very high. When this transportation cost of to and fro is added to recycle the product, then the scrap plastic becomes costly than the fresh plastic. जब हम ये कॉस्ट जोड़ देते हैं कि एक बार बेचे फिर उसको खरीद के दोबारा लेकर के आए इकट्ठा करके एंड देन रिसाइकल किए, इस कॉस्ट को जोड़ देते हैं तो स्क्रैप प्लास्टिक हमारा महंगा हो जाता है, and that is the reason it is not competent in the market. And market runs on economy, market does not run on emotion. So if the product is not economically viable, this will not pick up in the market. So this is the reason why scrap plastics or recycled plastics are not very popular in the market, whereas fresh plastics are popular. The very much reason is the low cost of the fresh product as well as high transportation cost leads to the heavy cost of the scrap plastic, which is basically not competent with the fresh product. So that's the reason plastic recycling is not very popular across the globe, but it must be promoted, because if we are not promoting the recycling of the plastic, then it is going to be one of the biggest challenge to our environment. So in order to protect our environment, at least we should start thinking about the banning of new plastics, या नए प्लास्टिक को तो कम से कम मार्केट में नहीं आने देना चाहिए. So please note it down, ये सारी चीजें लिख लीजिए. You started from here, initiation, जल्दी से लिख लें. This is all about initiation polymerization, addition polymerization. Please do it quickly. Please do it quickly. Yes, Nishtha, there are certain NGOs, they are doing these things, but that's not at the large scale. Because in every city there cannot be a factory to produce these plastic materials. So ultimately, even if we are collecting somewhere, it need to be transported, and that transportation cost is becoming a huge hurdle. And market actually never runs on emotions. Market is basically running on the input cost and the output from that cost, all those. But still there are certain NGOs, certain social welfare organizations, they are trying to promote recycling of the plastic. Even if you see, recently government of India has announced that single use plastic should be banned from the country. Single use plastics are basically those plastics which are used once and they are thrown away, like your poly bags, wraps, certain polythene which is used for the wrapping purpose, toothpick, or your earbuds, all these are the plastics, they are the single use plastics. So these single use plastics has been banned by the government of India. Although the law has been enacted, but it is not beautifully implemented, and that's the reason we are not able to overcome this problem. Although I have not I have actually there should be some alternate produced, and that alternate should be economic, cost wise it should be competent, then only you can overcome this problem. जब तक आप कोई अल्टरनेटिव प्रोडक्ट मार्केट में नहीं लेकर के आओगे जो कॉस्ट वाइज इनको compete कर सके, तब तक इसकी कोई रेमेडी नहीं होगी. वैन लगाना is not a solution. Like someone is, if from northeast, and he is in the class, he or she is in the class, so I'm very happy with the northeastern part of the country. When I visited northeastern part of the country, then I saw they are very aware about the protection of their environment. So what they have did, they have used the material which is available over there, like bamboo and wooden things, they are using over there, and they are trying to replace the plastic. So I found very less plastics to be used in the northeastern part of the country, and that's why they the environment is protected over there, and that looks a very beautiful part of the nation. So that kind of solution need to be there. Like I saw in some of the states over there, they are using bamboo made dustbins, they are using bamboo made things to carry bags, they are using bamboo for the water bottles. Water bottles are also one of the big contributors. You see, most of the cases we drink water and throw it, so that is a plastic and we are throwing it. So I didn't found there ki tea is served in the plastic glass. Tea is served either in the paper glasses, or it is in the glass of कांच से बने हुए, and all those kind of things were used, or steel was used. So that kind of small changes is required to overcome this problem. Otherwise it is going to be a big problem in the future, right? So nowadays I see paper-based straws in beverage. Yes, that is the reason, because the government has banned single-used plastic, and straw is also single-use. Sir, भारत के नागरिक होने के नाते हम क्या कर सकते हैं surface level पर? As a citizen of, as a aware citizen, we should try to use at least less, and we should promote people to use less plastic-based products, and particularly those plastic-based products which are single-used. अगर हम उनको कम कर देंगे तो हमारा काम चल जाएगा. सो वी शुड प्रमोट इट, कि जैसे हम मार्केट जाते हैं, लेट अस सपोज वेरी स्मॉल थिंग बट इट विल हैव अ वेरी लार्ज इफेक्ट. वी गो टू द मार्केट टू बाय वेजिटेबल्स, and we do not carry a bag, so the vendor gives us each and everything in small poly bags. Now these small poly bags are useless for you once you take the vegetable and then you throw it out. That is becoming a big challenge for the disposal. So the best thing is you should carry a handbag that may be made of jute, that may be made of कपड़े का या किस इस तरह से बना हो सकता है। सो अगर आप बैग कैरी कर रहे हैं, सो यू नीड नॉट बी टेकिंग दैट प्लास्टिक, एंड दिस वे इट कैन बी प्रमोटेड। अब धीरे धीरे अगर एक पर्टिकुलर सोसाइटी में सभी लोग बैग लेकर के जाने लगे, तो जो वेंडर है वो प्लास्टिक खरीदना बंद कर देगा, और वो प्लास्टिक खरीदना अगर बंद कर देगा तो इन्वायरमेंट में एक बड़ा कंट्रीब्यूशन आपकी तरफ से हो गया कि आपने प्लास्टिक को आने ही नहीं दिया। सो ऐसी छोटी छोटी चीजें, तमाम सारी चीजें इंप्लीमेंट की जा सकती है। बच्चों को छोटी एज से, द किड्स व्हिच आर ग्रोइंग एज ऑफ नाउ, दोज हु आर 5 years 6 years 7 years, to teach them don't use plastic bottles, try to avoid at least using plastic bottles, give them water bottles which are made of metals, or which are made of bamboo and like that kind of things. When you are going to purchase vegetables in the market, take them with you and try to teach them that we should not take these polybags, and let us carry a bag made of jute and all that, घर से लेकर के जाइए. So in early age if you start putting these things, so when they will grow up, these would be hidden in their mind, and they will start using in the same manner. So इस तरह की कुछ चीजें की जा सकती हैं. Our DC encouraged making polybricks out of polyethylenes, and it was implemented in our district. Is polybrick a safe disposal of at least Sunanda, it's not a safe disposal, but if it can be commercialized, then a large chunk of polymers can be converted into the some other product, and that product is basically brick. So brick can be used to make the structures. So somewhere we can tackle this problem, but I hope that project, I was also reading somewhere it, but that is not very economically viable. The biggest challenge is ki economically viable product should be there, which is competent in the market. So that poly brick, I didn't find that ki that is economically viable, ki people would be buying it. If it becomes economically viable, then obviously that is one of the good solutions. Cloth wax used in UP, sir. Yes, use karna chahiye. Basically we should go for substitute. Yes, the best thing is ki as much as we can avoid, we should go for the substitute of the polymers, जितना भी ज़्यादा हम अवॉइड कर सकें. नेक्स्ट चलते हैं. नेक्स्ट वन इज कंडेंसेशन पॉलीमराइजेशन. नेक्स्ट इज कंडेंसेशन पॉलीमराइजेशन. Condensation polymerization. This is also known as step reaction. This takes place in the monomers which have functional groups, and there can be two functional group or more than two functional groups. Earlier you were having a monomer which was having double bond, but here the functional groups are necessary. Like we take phenol, this is our phenol OH, right? And when this phenol reacts with formaldehyde, SCHO is formaldehyde. This is formaldehyde. So this reaction gives bakelite. Formula of the bakelite is given in the book, you can see. So this bakelite is phenol formaldehyde. It is your polymer, phenol formaldehyde. This is your polymer. This is your polymer. And plus you will get H2O. This H2O is byproduct. It is basically wastage. So the best way to identify this reaction is कि in this reaction you are getting a small molecular weight byproduct. ये H2O हो सकता है, HCl हो सकता है, NH3 हो सकता है, alcohol हो सकता है, कुछ भी हो सकता है. There can be several things depending upon कि किस तरह का functional group आपने लिया है. Accordingly you can have. What is the beauty of this reaction is कि you have more than one active centers. Even if one active center is blocked, this is having three active centers, so the chain can grow at two places. So if the chain is growing at two places, so you can get branched structure, and there is a possibility that these branches will cross link each other, and if the branches are cross linking each other, you may get a strong polymer. You may get a branched structure, and if branches are connecting with each other, you may get cross link structure. हालांकि branches are not connecting with each other, then it would be thermoplastic. But if the branches are connecting each other, then it cannot be thermoplastic, because now if you heat, you do not have van der Waals force, you have primary bond, so it will not become a soft liquid. So by heating, it cannot be recycled or reshaped. So such kind of polymers are known as thermosetting plastic, means they are set with respect to temperature. एक बार आपने इनको बना दिया तो आप अब दोबारा हीट करके इनके शेप को चेंज नहीं कर सकते हो. So such plastics which are not able to be reshaped or recycled by heating again and again, they are known as thermosetting plastic, right? So thermoplastic and thermosetting का difference समझिए. Thermoplastic materials on heating can be recycled or reshaped n number of times, whereas thermosetting cannot be recycled or reshaped for n number of times. Once they are made, then now on heating they cannot be reshaped, they are set with respect to temperature, you cannot recycle them. So such kind of plastics are known as thermosetting plastic. But the beauty of these thermosetting plastics is they are stronger than the thermoplastic materials. They are, because they have branches and those branches may couple with each other, so their strength is higher than the thermoplastic material. And you see one more thing, thermoplastic was formed with addition polymerization, and addition polymerization is basically the reaction where free radical is participating. Free radicals are highly unstable, so reaction is very fast. But here two stable groups are participating to make the product. So if the two stable groups are participating to make the product, then reaction cannot be that fast as it was earlier. So this is a slow reaction as comparison to the addition polymerization. लिख लेते हैं इसको, पहले ये लिख लीजिए, फिर इसको डिफाइन कर लेते हैं. Please note it down, then we would be defining it. दैट्स गुड निस्था. मैंने कहा कि जितना हम अवॉइड कर सकें उतना करना चाहिए. अब जब नहीं अवॉइड कर सकते किसी जगह पर, तो उस जगह पर तो कोई बात ही नहीं है, देन वी आर बाउंड टू यूज. लिख लिया? लिखें जरा कंडेंसेशन की डिफिनेशन. कंडेंसेशन पॉलीमराइजेशन, कंडेंसेशन पॉलीमराइजेशन, condensation polymerization is the formation of polymers, is the formation of polymers formation of polymers by stepwise intermolecular chemical reactions. Intermolecular chemical reactions that may involve that may involve that may involve more than one monomer species. यहाँ देखो दो लिया है हमने, एक SCHO और दूसरा फिनॉल. that may involve more than one monomer species. That may involve more than one monomer species. Full stop. There is usually a small molecular weight. There is usually a small molecular weight byproduct, a small molecular weight byproduct there is usually a small molecular weight byproduct such as water, HCl, alcohol, etc. such as water, HCl, alcohol, etc. etc. Full stop. The monomers involved in the monomers involved in condensation process, the monomers involved in condensation process should have functional groups, should have functional groups instead of multiple bond, instead of multiple bond, should have functional groups instead of multiple bond. इंस्टेड ऑफ मल्टीपल बॉन्ड। ठीक है जी, लिख लिया। अब एक टेबल बनाते हैं। Let us make a table. In that table, let us try to compare addition and condensation polymerization. Addition polymerization. And here condensation polymerization. Addition में you can write it demands presence of multiple bond, यानी डबल या ट्रिपल बॉन्ड, presence of multiple bond in monomers. यहां पर लिखेंगे monomers should have functional groups. Monomers should have functional groups. Second, after this चाहिए, in the addition polymerization there is no byproduct, but in condition there is a byproduct. Condensation there is a byproduct. There is no wastage or byproduct formed. यहाँ लिखें a small molecular weight, a small molecular weight byproduct is formed. A small molecular weight byproduct is formed. थर्ड आते हैं, लेट्स गो फॉर द थर्ड. नहीं, Sunanda is asking, sir, do branched polymer and cross-linked polymers both come under the type of thermosetting? No. If branches are connected, then it is thermosetting. If not connected, then it would be thermoplastic. Because for thermoplastic there should be van der Waals forces. So if branches are not connected, मान लो कि ये branch polymer है but branches are not interconnected, it means chains would be connected through the van der Waals force, then that is thermoplastic. But if the branches are connected through the primary bonds, yani it is cross linked, so if it is cross linked, then thermosetting. Third, reaction is fast. Reaction is fast because it is due to the free radicals and they are highly reactive. Reaction is slow. You see, in the addition polymerization, there is only one active point from where chain is growing. That's why it is linear. But here, there can be more than one active point, at least two active points of where the chain would be growing. So, you can write chain growth is observed at, chain growth is observed at one active center, observed at one active center. यहाँ लिखेंगे chain growth is observed at, chain growth is observed at two active centers, at two active centers. ठीक. Fifth one, the fifth one is polymer formed is thermoplastic type. Polymer formed is thermoplastic type. क्योंकि यहाँ तो चेन ही नहीं बन रही है तो क्रॉस लिंक होने का चांस ही नहीं है. यहाँ जैसा मैंने बताया कि there would be branch polymers, so if the branches are connected then thermoset, not connected then thermoplastic. So polymer formed may be thermoplastic or thermoset. Thermoplastic or thermosetting. Please note it down. The comparison between addition and condensation. Quickly do it. Drishti is asking kitni class bachi hai. Tomorrow would be the last class for this subject. GS के लिए. टेक्निकल जो EC इलेक्ट्रिकल का है दैट इज लेफ्ट और आपको शेड्यूल शायद प्रॉपर नहीं बताया गया है. टुडे देयर इज नो क्लास फॉर द टेक्निकल मटेरियल साइंस. Tomorrow 1 p.m. onwards I will be continuing the technical material science for EC and electrical. Tomorrow at 12 p.m. this would be finished. So tomorrow I would be continuing from 1 p.m. onwards the technical part of the material science. आज शायद जो इलेक्ट्रिकल के लोग हैं उनकी 1 बजे से पावर इलेक्ट्रॉनिक्स की क्लास है. So you would be continuing with the power electronics class. There is one more small topic I need to discuss in this. So let's discuss that topic also. That is elastomers. Elastomers. These are basically rubbers. ये rubbers हैं. These are elastic materials. when you stretch them, they will produce a strain, and if you leave it, they will again retain their size. So, these elastomers are also known as rubber, and these polymers have these polymers have elastic deformation greater than 200%. So, very large elastic deformation. They are elastic materials, but they do not follow Hooke's law, because Hooke's law के लिए stress should be directly proportional to strain. Here for a small strain they have large, for a small stress they have large strain, so they do not follow Hooke's law. These are basically thermoplastic material which have coiled like structure. So, either these chains are connected with the van der Waals force, or they are lightly coupled. So, they are not strongly coupled. When you stretch, these van der Waals forces get finished and they start stretching, but as soon as you leave, they again regain their size and van der Waals forces are reformed. So, this is the basic mechanism in these materials. So, you can say write these polymers may be these polymers may be thermoplastic or lightly cross-linked thermosets, or lightly cross-linked thermosets, lightly cross-linked thermosets. These polymers have coil-like structure. These consists of coil-like structure. These consist of coil-like structure. That can be reversible stretched. That can be reversible stretched by applying force. These rubbers have several applications. Industrially, they can be used for flexible coupling. Wherever you need flexible coupling, you can use them. Flexible coupling. Then you can use them to make pneumatic tires and tubes. जो आपके automobiles वगैरह में tires and tubes होते हैं. So you can use them to make tires and tubes. You can use them to make gasket. ऐसे इंजन में जरूरत लगती. So several places you can use them. But the problem is, since they are thermoplastic, so their strength is very less. So if you are wanting to enhance the strength, you have to connect them, to couple them. So the process of cross-linking of chains in the elastomers, that is known as vulcanization. So vulcanized rubber is basically cross-linked polymer, and cross-linked polymers are stronger than the normal. So vulcanized rubber is stronger than the normal rubber, unvulcanized rubber. And this process of cross-linking of chains is known as vulcanization, right? So vulcanization. The process of cross-linking of chains in elastomers is known as vulcanization. The process of cross-linking of chains in elastomers is known as vulcanization. Done? Shall we go ahead? This cross-linking of chains is achieved with the help of sulfur. Yeah, it can be achieved with the help of oxygen. कुछ लोग पिछली स्लाइड देखने को कह रहे हैं, कौन सी स्लाइड छूट गई भाई? This one, quickly do it. Done? या ये वाली अगर देखना था तो क्विकली डू इट, पिक्चर ले लो इसकी. Let us see how the vulcanization can be achieved. Suppose I am taking the example of natural rubber. The chemical name of natural rubber is polyisoprene. This is basically polyisoprene. Suppose we have a mer. Mer is basically chain, representing a chain. C, C, double bond C, C, and like this. It is a single mer. Here it is H, H, CH3, H, H, and like this. So you can grow the chain like this. You connect, keep on connecting. So it is a mer, keep on repeating, it will become a polymer, and that polymer is nothing but natural rubber, polyisoprene. You remove this CH3 and put H. So the structure will become polybutadiene, and polybutadiene is known as synthetic rubber. So there is already a question related with synthetic rubber in the book. So I am thinking to cover it natural rubber in the notes, so that both of them can be covered. The only difference is CH3 is removed, and in place of CH3 you connect with H, that will become polybutadiene, that is synthetic rubber. So this is one chain, and in this chain there is a double bond. So this double bond gives us the flexibility to connect the chains. How? Have a look. Let us suppose there is another chain, H, H, C, and CH3, double bond C, H, C, H, H, like this. So if I break these two bonds, then one active center here, one here, one active center here, one active center here, and this can be cross-linked. So as soon as we add sulfur या oxygen, cross-linking can be achieved with the help of any one of these two. So as soon as we add, the chains will get broken. Like this. Like this. So now as the bond is broken, one sulfur is connected here and another sulfur is connected here. This is your vulcanized rubber that has been cross-linked, vulcanized rubber. And this one is your unvulcanized rubber. This is unvulcanized rubber. So the process of cross-linking of chains in rubbers is known as vulcanization. Sometimes they ask numerical problems कि 200 किलो vulcanized rubber बनाने के लिए how much sulfur is required. जरूरी नहीं 200 किलो, 100 किलो, 500 किलो, whatever they can ask. So learn the procedure. 2 moles of the rubber need how many sulfur? 2 sulfur. It means 1 mole is requiring 1 sulfur to get 100% cross link. 100% cross link means there is no further possibility to cross link. All the sites which were able to cross link, they has been cross linked. So 100% cross linking is achieved. So I can say that for each mole we have 1 sulfur atom. So molecular weight of 1 mole of vulcanized rubber, किसी वल्कनाइज्ड रबर के 1 मर का मॉलिक्यूलर वेट क्या है जरा देखिए, 1 2 3 4 5 कार्बन एटम्स, 5 into 12 प्लस हाइड्रोजन कितने हैं, 1 3 4 5 6 7 8 हाइड्रोजन एटम्स. This is not the final story. With each mer there is 1 sulfur also, so molecular weight of sulfur is 32. It means the molecular weight of a single mer is 68 plus 32 gram per mole. To vulcanize this much of rubber, how much sulfur is required? 1. So I can write for cross linking of each mer 1 sulfur atom is required. Hence 68 plus 32 gram per mole of vulcanized rubber need sulfur that is 32 gram per mole. इसलिए 1 unit of vulcanized rubber need sulfur 32 gram per mole divided by 68 plus 32 gram per mole. So this gram per mole will get cancelled. These are getting cancels. So it will become in fraction 32 upon 68 plus 32. It will come into fraction. That's why let us suppose 100 kg, 200 kg, whatever, 100 kg of vulcanized rubber need sulfur is 32 upon 68 plus 32 into 100 kg. So this come out as 32 kg. Suppose he asked that you vulcanize it by oxygen, so instead of 32 you can write 16, that is the molecular weight of oxygen, atomic weight basically. Similarly, if he is saying that 20% vulcanization is required, so for 100% if it is 32 kg, so for 20% how much? 32 multiplied by 0.2. For 50% how much? 32 multiplied by 0.5. So this way you can calculate. So such kind of numerical problems are also sometimes asked. So please write down the vulcanization and related numerical. Vulcanization लिख लीजिए. The process of cross linking of chains in elastomers is known as vulcanization. Quickly do it. Done? Quickly note it down. So polymer is over. Now two topics are left, जिसमें one is phase diagram and alloys. So basics of phase diagram and alloys I will be covering. इससे काफ़ी क्वेश्चन आते हैं. And the other is composites. In last 6 years, no questions has been asked in composites. So in composites, I do not dictate notes. I would be talking few things बिना कुछ लिखाए हुए. You have to read it from theory book. So I would be explaining the basic concepts behind it, but will not be giving any notes. I never give notes in composites. इनफैक्ट आई एम थिंकिंग कि अगर इस साल भी इससे क्वेश्चन नहीं आया तो मैं इसे हटा दूंगा, सिलेबस में भी अगले साल नहीं रखूंगा, बिकॉज इन सिंस लास्ट 6 years आई डिडंट गेट एनी क्वेश्चन इन जनरल स्टडीज पेपर from this topic. Although the questions are asked in mechanical engineering, electrical engineering from this topic in their technical part, but in GS they are not asking. So for this I will not be giving you any notes. At the end I would be covering it and briefly I would be covering it. For this I would be giving you notes and would be talking in depth. Tomorrow your class timing for GS is 9 AM to 12 noon. GS material science, basically basics of material science. For EC and electrical, technical material science, basically पेपर टू के लिए जो चाहिए, this will start from 1 PM onwards. This will start from 1 PM onwards. So this is the tomorrow's class schedule. Tomorrow class schedule. आज के लिए बस इतना ही. We have covered polymers. So for today we have only this much of the things. Tomorrow I will be starting with phase diagram and alloys. We'll be finishing it in 2 hours. Then 30-40 minutes we would be talking about composites. Roughly, not even that. Briefly we would be talking. किसी ने कहा last 2 slide दिखाने का, तो take the picture quickly. Take the picture. Then see it. Last slide. Thank you. Have a wonderful time. Yes, technical is the first class, but उसमें वही चीज़ें पढ़ाऊंगा जो आपको GS में नहीं पढ़ाया हुआ है. So up to crystallography knowledge in GS is required, and whatever is left to be discussed over there, that would be taught in technical. It is the first class tomorrow for the technical material science.